IXL section V4, multiplication with exponents. Whenever you multiply two terms with the same base, you can add the exponents. So if you look at our first example, I'm multiplying two terms and they both have the same base. Remember, the base is the big number. Alright, so if they both have the same base, you could just add their exponents. So I'm going to add the exponents of 2 plus 3 right here. So my answer would be 2 to the 5th power. And the reason that works is because if we take a look at what 2 to the 2nd power means, that means 2 times 2. And I'm multiplying that times 2 to the 3rd power, which means this. All right, 2 to the 2nd power times 2 to the 3rd power means in total, I'm multiplying 2 times itself 5 times. So in total, I have 2 to the 5th power. That's why it works. If you look on the right-hand side, I got the rule. So if you look at the rule, both terms have the same base. They have the same letter, so that means they have the same number in the base. So whenever I have that situation, when I'm multiplying and I have exponents and the base is the same, I just add the exponents to get my answer. Cuando están multiplicando dos términos con la misma base, se puede sumar los exponentes. Así que aquí en el primer ejemplo estamos multiplicando 2 a la 2 por 2 a la 3. Los dos tienen el mismo base que es el número 2, el número grande. Así que puedo simplemente sumar los exponentes 2 más 3 y la respuesta final sería 2 a la 5. Eso trabaja porque si miramos 2 a la 2 quiere decir 2 por 2 y estamos multiplicando eso por 2 a la 3 que quiere decir 2 por 2 por 2. En total estamos multiplicando el número 2 por él mismo 5 veces, así que es 2 a la 5. Y aquí tengo escrito la regla, ¿ok? Estoy multiplicando con exponentes y los dos términos tienen la misma base representado por el variable x. Así que simplemente sumo los exponentes. Vamos a mirar algunos ejemplos. All right, so if you look here, all the examples in today's IXL are going to have the same base. Okay, todos los ejemplos en el IXL de esta sección tienen la misma base. All right, so they both have the letter T in this first example. And I just got to add the exponents. So the answer would be 2 to the 8th power. T to the 8th power. I'm sorry, T to the 8th power. T a la 8. It says express your answer using positive exponents. So I'm just doing that, all right? Here, same thing. M to the 4th power. I add the exponents. Sumo los exponentes. Right here, P to the 10th power. Right here, V to the 9th power. U to the 10th power. And Q to the 9th power. Look how easy that is, okay? I'm just adding the exponents. Okay, simplemente se suma los exponentes. Bien fácil. Okay, a few more examples. 3 plus 0 is 3, so my answer here would be W to the 3rd power. Remember that any number to the 0 power is 1, so you could also think about this as W to the 3rd power times 1 equals W to the 3rd power. Recuerden que cualquier número con un exponente de 0, cualquier número que no sea 0 con un exponente de 0 es igual a 1. Así que pueden pensar de esto como W a la 3 por 1 es igual a W a la 3. All right, here we have some negative some negative exponents. All right, so again, you just add the exponents to get the answer. Negative 4 plus negative 1 equals negative 5. Here, when I add negative 1 plus 7, I get positive 6. Here, when I add... By the way, going back to this one, look at the directions. In case you're confused as to how we should write this answer, it says express your answer as a single term without a denominator. All right, so they do not want us to write it like this because as we learned in a previous IXL with negative exponents, if I get rid of the negative sign in the exponent, I would write it like this. But for this question, if you look at the directions, they don't want you to write a fraction. They just want you to write it like this, okay? En este ejemplo, en la dirección en las direcciones dice que tiene que simplificar y expresar la respuesta como un término, un término singular sin ningún denominador. Así que no querían una fracción, porque lo podría haber escrito de esta forma, pero si lo escribo sin denominador sería así. Alright, so same thing with this one. Okay, aquí es la misma cosa. So my answer when I add the exponents would be a to the negative 4 power. Okay, dice aquí que no quieren un denominador. Alright, this one, when I add, okay, look at this one. This one's interesting. Alright, there's no number here, so if there's no exponent, it's understood that there's an invisible 1 right there, okay? Aquí no hay un exponente con la S, pero si no hay un exponente, he entendido que es un 1 invisible. ¿Ok? Así que cuando lo multiplico, tengo que otra vez sumar los exponentes. 1 más negativo 1 me da 0. Y cualquier número con un exponente de 0 es igual a 1. Cualquier número que no sea 0. Alright? So here when I add the exponents, I'm going to get s to the 0 power. Remember, any non-zero number to the 0 power will always equal 1. So the answer here is 1. And then this one, pretty straightforward. Just add the exponents, and you're going to get k to the negative 36 power. All right, now here are the problems that you're going to get in the challenge zone. It's the same thing I just did, except it's like several problems in one, because you got to do each base or each letter one at a time, okay? So first I'm going to do the letter F, then the letter G, and then the letter H. But I'm doing the exact same thing I did in every problem so far, okay? Aquí, estos son los problemas que salen al final. Es lo mismo que acabo de hacer. Lo único es que tengo que hacer cada variable uno a la vez. Primero voy a hacer la letra F, después la letra G y al final la letra H. Así que la letra F. Okay, what exponent does the F variable have here? Nothing. So it's understood that there's an invisible 1. Okay, la F no tiene un exponente, así que he entendido que hay un 1 invisible ahí. So F to the 1 times F to the negative 10, that's going to equal F to the negative 9. Alright, so that's the first part of my answer. Ahí está la primera parte de mi respuesta. Sumé los exponentes y la F se mantiene. Alright, now let's look at the letter G, la letra G. G to the negative 50 power times G to the 44th power. I add their exponents and I'm going to get negative 50 plus 44 is negative 6. And the last one is H. H to the 0 power times H to the 30th power. 0 plus 30 is 30. Again, look at the directions. They want you to write your answer without a denominator. All right, so they want me to leave it like that, not get rid of the negative sign in the exponent, which I could do, but they don't want that. They don't care for that right now. They just want you to write your answer like that. All right, listen, I'm going to tell you right now, these questions are simple, but it's very easy to make a mistake. Even I made a mistake when I was doing it quickly, not paying attention. It's very easy to look at it quickly and not see whether that exponent is with a G or with a F, which is the mistakes I made. So look at it carefully because it's easy to miss something. Okay, así que aquí hice cada variable uno a la vez. Si miran las direcciones dicen que quieren que le escriben la respuesta sin un denominador. Así que escribo mi respuesta de esta forma. No tengo que quitar el signo negativo del exponente. Y fíjense bien en dónde están los exponentes, porque estos problemas son fáciles, pero también es muy fácil hacer un error, porque hasta yo lo hice cuando no me fijé bien cuál exponente estaba con cuál variable. All right, so here's another example. Again, do one letter at a time. Hagan una letra a la vez. So b to the 0 power times b to the negative 3rd power equals b to the negative 3rd power. C to the negative 1 times c to the 4th power equals c to the 3rd power. And d to the 7th power times d to the... Remember, if there's no exponent, there's an invisible 1. Recuerden que si no hay un exponente, que hay un 1 invisible. So this is going to give me d to the 8th power. And that's my answer. Ahí está mi respuesta. All right, here, u to the 0 power. Let me write that better. U to the 0 power times u to the 1st power equals u to the 1st power. V to the 4th power times v to the 0 power is equal to v to the 4th power. So my answer is u v to the 4th power. The 1 you don't write it. No se escribe el 1. Over here, there's just one letter, so one variable, so I'll just leave that. And 63 plus 0 is 63. So that one's easy. All right, here if I multiply the s's, I got s to the 1st power times s to the 1st power, so that equals s to the 2nd power. T to the negative 6 power times t to the negative 1 power. Add the exponents and you get t to the negative 7 power. And u to the 6th power times u to the 61st power equals u to the 67 power. All right, I believe there's 2 more examples. All right, so here, a to the 9th power times a to the negative 9th power equals, all right, this one, 9 plus negative 9 is 0. And any non-zero number to the 0 power equals 1. So basically for a, I don't write anything in my answer. Because when it's 1 times everything else, the 1 is going to vanish, right? Aquí como a a la 9 por a la negativo 9 me da a la 0. Y cualquier número que no sea 0 con un exponente de 0 siempre es igual a 1. Así que la a no lo tengo que escribir en mi respuesta. The b's is going to be b to the 0 power times b to the 1st power. So that equals b to the 1st power. I don't write the 1. C to the 1st power times c to the 1st power equals c to the 2nd power. And d to the negative 82 power times d to the negative 71 power. I add the exponents and I'm going to get negative 153. And there's my answer, and we got, I think, one more. All right, so r to the 0 power times r to the negative 80 power equals r to the negative 80. S to the negative 2 power times s to the negative 1 power equals s to the negative 3 power. All right, that concludes this lesson for IXL section V4.